Come, boy girl, let me prove my claim. And my claim is Riemann zeta of 0 is equals to minus 1 by 2. And we will prove this statement in this video. Okay, so basically we can define Riemann zeta in two ways, by integral representation I mean. So the well-known one is Riemann zeta of s is 1 by gamma of s integral from 0 to infinity of x to the power s minus 1 by e to the power x minus 1 dx. Yeah. Another is first of all we take the integral representation of eta of s. Yeah. And then from eta of s we change to zeta of s by the formula. We have a formula, and this is here's plus for the eta of s, and we know that this eta of s is actually equals to 1 minus 2 to the power 1 minus s zeta of s. Yeah, so that's why zeta of s will be eta of s by 1 minus 2 to the power 1 minus s. Yeah, so we can use this formula and then get another integral representation. That means we can get zeta of s is equals to eta of s by 1 minus 2 to the power 1 minus s. Yeah, and then 1 by gamma of s. Yeah, and then sorry, I did make okay, so instead of eta of s, since I'm placing this value, so I did not write it here again. Yeah, and so I get integral from 0 to infinity of x to the power s minus 1 by e to the power x plus 1. Okay, so now we will make some manipulations in this integral. Yeah, we will use integration by parts, and then we will use the new formula that we get to find zeta of 0. Yeah, because if we try to apply zeta of, if we try to solve it as equals to 0 right now, like this gamma of 0, we don't know about the value of gamma 0. Yeah, that's why if we use integration by parts, we will get 1 by s over here, that makes it gamma of s plus 1, and then we will substitute value. And in that case, if this over here was minus 1, there will be trouble again. So that's why I will not use this definition, but we will go through this, make some manipulations, substitute s at 0 to find zeta of 0. Yeah, let's do it. So first of all, let's use the integration by parts. Zeta of s equals to 1 by 1 minus 2 to the power 1 minus s 1 by gamma of s, and then this is, so firstly let us write 1 by e to the power x plus 1 as it is, and the integral of this will be x to the power s by s. This is going from 0 to infinity. Yeah, and then minus of integral from 0 to infinity. Now derivative of this expression is minus 1 by e to the power x plus 1 whole square times e to the power x. Yeah, the integral of this is x to the power s by s dx. Yeah, now zeta of s will be 1 by 1 minus 2 to the power 1 minus s 1 by gamma of s. Yeah, now over here at infinity, this e to the power x in denominator will dominate. This will be 0, and at 0, and this is over here it's 0, so that's why again it's 0, and this is minus minus plus, and 1 by s comes out, and integral from 0 to infinity x to the power s e to the power x by e to the power x plus 1 whole square dx. We get this. Yeah. Now we take 1 by s outside. That gives us zeta of s is equals to 1 by 1 minus 2 to the power 1 minus s. Yeah. 1 by gamma of s plus 1, and this integral from 0 to infinity x to the power s e to the power x by e to the power x plus 1 whole square dx. And only now we can substitute. We will substitute the value, because now this is defined and there's no problem. So if you substitute s at 0 now, over here this is 1 minus 2 to the power 1, so that's minus 1, and this is gamma of 1, and this is the integral from 0 to infinity of x to the power 0 e to the power x by e to the power x plus 1 whole square dx. Yeah. Now we can take 1 minus 1 inside the over here in integral. Yeah. And that gives us integral from 0 to infinity. That will just be minus e to the power x by e to the power x plus 1 whole square dx. And now we know that earlier, to get this expression, we just differentiated 1 by e to the power x plus 1. Yeah. That's why now if we integrate, we get the same original expression. We get zeta of 0 equals to 1 by e to the power x plus 1 going from 0 to infinity. At infinity this is 0 minus at 0 this is 1 by 2. Yeah, 1 by 2. So the answer is minus 1 by 2. That's why we can so zeta of 0 equals to minus 1 by 2. So if we try to go with the sum definition of zeta of 0, we know that zeta of s is equals to sum from n equals to 1 to infinity of 1 by 1 to the power s. Yeah, so 1 by n to the power s, not 1. So now if you find zeta of 0, this is just sum from n equals to 1 to infinity of 1 by n to the power 0, so that's 1 by 1 actually. So this is sum of n equals to 1 to infinity of 1. This is minus 1 by 2. Wow. Okay, so hope you enjoyed this, and talk about the flow. We use the definition of eta and then change it to zeta, is integration by parts, and then this one changed to some newer formula, and yeah, that gave us the answer. Hope you enjoyed the video. Thanks for watching, and look forward to seeing you in the upcoming videos too.